Hello, and welcome to this tutorial on correct calculations, where we'll look at order of operations and correctly doing calculations on a financial calculator such as the Texas Instruments BA2 Plus. Let's start with the problem. How would you evaluate the expression below? And the correct answer is one of these five given in the list. So why don't you pause the video and think about this for a minute. Okay, so the way to do this is you have to recognize what the proper order of doing the calculations, and you need to follow what's called PEMDAS, which is to do them in the order of first items within parentheses, then exponents, then multiplication and division, and then addition and subtraction, where these are categories where you would go left to right within. So there are no parentheses, so we would start with exponents. And we have one exponent here, 2 squared, and that's 4. So the expression then would become this. So now we look at multiplication and division, and we would first do 4 times 4, not because it's multiplication, but because it's the leftmost within that category. So 4 times 4 is 16, and then we do 6 divided by 2, that's 3. So then we move on to addition and subtraction. And here we'll do the subtraction first because that's leftmost. So 14 minus 16 is -2. And then we add 3 and we get the answer, 1. So 1 is the correct answer. If that's what you got, congratulations. Now there's a mnemonic that some people like called, "Please excuse my dear Aunt Sally." Personally, I just prefer to remember PEMDAS, but if the phrase works for you, go for it. All right, so let's look at another illustration. Here we have a simpler expression, 1 plus 4 times 3 squared minus 5. So again, there are no parentheses. We're going to do the exponent first, then the multiplication, then the addition, and then the subtraction. So 3 squared becomes 9, 4 times 9 becomes 36, 1 plus 36 becomes 37, 37 minus 5 is 32. So we're doing exponents, multiplication, addition, and subtraction. Now if we wanted a different order, we would need to actually put parentheses in this expression. If we wanted to actually do it from left to right, doing 1 plus 4 first, then multiplying that by 3, and then squaring that, we'd have to put in parentheses to make that happen. So doing it this way, we would get 1 plus 4 is 5 times 3 is 15, and we square that, and that's 225, minus 5 is 220. So we're still doing PEMDAS, but the parentheses then force these operations to the top of the order. And you see that we get a very different result, 220 versus 32 with no parentheses. So now let's look at our calculator, and we're going to need to make some changes to do this properly. The default settings on the TI BA2 Plus are such that calculations are actually done in the order entered. That's called change mode. So if we were doing a calculation, and let's start by clearing our memory, so we do that by hitting the clear key twice, and we wanted to take 1 plus 2 times 3, and we put that into the calculator, we'd actually get 9. And so what the calculator is doing is it's adding 1 and 2, and then it's multiplying it by 3. So it's chaining these in the order that they're entered. So if we don't want that to happen, we need to change the mode to what's called algebraic order, or AOS, and that will follow PEMDAS. So to do that, you hit the second key and then the period and then the up arrow, and you will see chain displayed, and that means that it's currently in chain mode. If you then hit second and enter, that will toggle it to AOS. And then if you hit second and CPT, you'll be back out. You'll quit out of the settings mode. So then let's see if it worked. If we then do the same thing, clear memory, and we enter 1 plus 2 times 3, you should get 7. And that result corresponds to 1 plus 2 times 3 in proper PEMDAS order. Now the second thing you may want to do is switch the display precision to floating point. The default settings on the calculator cause all results to be displayed to 2 decimal places. So, for example, if we were to enter 91 divided by 360 equals, that would show us 0.25, even though it's not precisely 0.25. There are actually some more digits to the right. If we were to enter 36 divided by 360, where that divides evenly, that would show up as 0.10, even though the answer is 0.1. It would show 2 decimal places. Now, I should note here that we're using the point to represent decimal places, and that's following the U.S. convention. So they'll do that for the rest of these presentations, as well as using comma then to express thousands or millions as a separator. So back to changing the floating point. How do we do that? Well, we again need to go into the settings. So we'd hit second and the period, and you should see displayed dec equals 2.00. If you then hit 9 and the enter key, you will see dec equals 9, and that means you've changed it to a floating point up to 9. And if you hit second and CPT, you will have quit and you'll get 0. Now, if you were to enter anything else besides 9 in here, less than 9, if you were to enter 8, it wouldn't be floating point. That would be giving you exactly 8 decimal places, or if you entered 4, it would be giving you exactly 4. So 9 is a special parameter that will give you floating point up to 9, and we'll see in a minute how that works. So let's do the same calculations. So we'll clear again. We had 91 divided by 360, and you'll see in the display 0.25, 27, 777, several sevens out 9 digits. And then if you do the one that divides evenly, 36 divided by 360 equals, you'll just see 0.1, no trailing zeros. So that's how the floating point. There's actually more digits after this, but it's rounding it to 9 digits. That's as far as it'll go. So that's how we set the precision. So now let's go on to a more complex problem, one that we might find in finance. And this is actually an expression that represents the forward FX rate. Now, if you don't know what this forward FX rate is or what this calculation is doing precisely, that's fine. The purpose here is just to make sure that you're able to mechanically do the calculations so that you can do it when the time comes for these types of computations. So what do we have here? We basically have this expression up here above in the numerator, and then we have the denominator here, another expression. So we're taking the ratio of these two, multiplying it by 3. Now, we could do breaking it up into steps on our calculator. So let's again clear. We could enter 91 divided by 360 times 0.07, and then add the 1 to it, equals, and you'll see that. And let's store that in memory. So if we hit the store key in 0, this will be stored in the 0 registry. So that represents this expression on the top. Then if we take 91 divided by 360 times 0.04 plus 1 equals, and then store that in the 1 registry, we'll get this, and that represents this expression on the bottom. And then what we can do is we can say 3 times reclaim 0, so that will reclaim what was in here, divided by reclaim 1, that reclaims that, and you will get this result. So you should try that and make sure that you can get these results, and pause if you need to. Now, you may say, well, wait a second, didn't we just set the calculator mode so we could do this in PEMDAS order? So we don't actually be so careful manually as we've done here. And that's correct. We could actually do this in one combined step. Now, what you need to recognize is that we'll need parentheses, even though there are no explicit parentheses here. The fact that it's sort of above this bar in the ratio indicates this is all evaluated together as one expression, and same for the expression below. So to do this, we'd go 3 times and then open paren on your calculator. 1 plus 91 divided by 360 times 0.07 close paren, and then we divide by and we go to what's on the bottom. 1 plus 91 divided by 360 times 0.07 close paren and equal. And you should get this, the same as you got here. So that is how you would do the computation for this rather complex expression. And we might want to round that to 4 decimal places. And we could do that just by looking at it. And we can see that actually, since the 2 is less than 5, this would round down if we wanted to go to 4 decimal places. So it would be approximately 3.0225. So let's do another problem we might see in finance. And this actually represents a forward interest rate. And so here, again, we have a ratio and an expression, but we got some exponents. So we're doing 1 plus 4.4%. And here we do have the parentheses because we want this to be sure that this whole expression here is raised to the 5th power. And then we take 1 plus 4.1% raised to the 4th power. And then that ratio is, from that, we subtract 1. So we could also do this in steps. So clear everything. Hit parentheses 1 plus 0.044, close paren, and then we would use the YX key to take it to a power, and then the power would come after, so 5 equals, and then we could store that in the 0 registry. And what would be stored would be this, 1.24 and more digits after. And then we can do the same thing for what's on the bottom here, but we're going to use different numbers. Open paren, 1 plus 0.041, close paren. Again, the YX key to take it to the 4th power. It equals, and here we'll store it in registry 1. And this is what the result should be there. And then we can, like we did previously, hit reclaim 0 divided by reclaim 1 minus 1 equals, and you will get this. But again, we could, if we've converted our calculator to AOS mode, we can do this more simply in one step. And in fact, we could even take the shortcut of not bothering to add here, but just recognize that 1 plus 4.4% is 1.044. So if you can do that in your head, you can just enter that, hit YX to the 5th power divided by, and then 1.041, YX to the 4th power minus 1. And you see you get the same result with many fewer keystrokes. And so that's the answer to that. And here we might want to express that in percent, just because it's an interest rate we're calculating. So we would essentially multiply this by 100, and if we want to round it to 2 decimal places in this case, it would round up, not down. So the 5.60808 becomes 1. So we'd have 5.61%. So again, you should be able to do these calculations on your calculator, the ones on the previous slide and this one. And if you don't do it now, while stopping the video, you should go back and look at the slides and attempt to replicate this to make sure your calculator is set up properly and you understand how to do these calculations. So let's summarize. For correct calculations, of course, the most important thing is you need to follow PEMDAS order when doing the calculations. For operations at the same category level, for example, multiplication and division, or addition and subtraction, we calculate from left to right. So even though we write PEMDAS, we need to be careful to understand that multiplication is not above division. These are actually at equal level, and then addition and subtraction are at an equal level. So this is above, followed by this, followed by both of these, followed by both of these. And then within any category, you go from left to right. So if we're set in algebraic mode, we should be able to enter it as they're written, properly interpreted, of course, including any parentheses, explicit or implicit, and you should get the correct result. Avoid writing down and re-entering intermediate results, as that could lead to loss of precision. So if you ever are in a situation where you have intermediate results that you need to save, use the store and reclaim keys for that, so that you preserve the maximum precision possible. And then finally, if you found this easy, that's great. If this is something you need to review and maybe other basic arithmetic operations, I would refer you to Khan Academy, and you can follow this link here. And this will have videos and exercises and quizzes on order of operations, as well as some other common arithmetic properties that you might need to review. So you might look at that. You might try doing the quizzes first. And if you need to go and look at some of the videos for the things that you need to understand better. So that's it. Thank you for listening.